All right, we're going to be doing circles still, and let's look at this next theorem that we're going to be studying that has to do with an angle inside. So this type of angle is called an inscribed angle. So far we've talked about a central angle. That's an angle that starts at the center point and goes out. This inscribed angle is going to be slightly different. So let's go get an inscribed angle is an angle formed by two chords. Oops. That share an endpoint. But notice that the endpoint this time is not the center. So it's formed by two chords. The vertex is shared endpoint on the circle. But both a central angle and an inscribed angle are inside a circle. But what's different from what we learned was the central angle is part of the circle formed by two radii. And the vertex is the center of the circle. So looking at these two examples of inscribed angles, notice that they don't touch at the center. So what would we call this? We would call this angle over here, this angle is inscribed angle ABC. Notice we say the B, because that's the vertex, as the middle point. And the intercepted arc, the arc that would be intercepted by that angle at the edge of the circle, the intercepted arc is called arc AC. Now let's go look at this next one. This time, the inscribed angle, notice it touches the edge of the circle now instead of the circle center, and so the inscribed angle would be angle EFG, and the intercepted arc is EXG. Notice that it's a two-letter name for this minor arc because it's smaller than 180, and it's a three-letter name for this major arc because it's over 180. So the same rules apply that we've already learned about the arcs and their sizes. All right, a measure of an inscribed angle is always half the measure of its intercepted arc. So the measure of an inscribed angle, here comes the formula or the rule, is equal to half of its intercepted arc. And then the measure of its intercepted arc, going the opposite direction, is equal to 2 times the measure of its inscribed angle. All right, why is this true? This is true because an inscribed angle is half the measure of its intercepted arc the semicircle is an intercepted arc that measures 180. So its inscribed measure is 90. Will always be 90. So let's draw a picture of that. If you've got a semicircle, picture that if you drew an inscribed angle that goes here to the edge of the circle, that they're saying that this angle measure is always going to be 90 because the intercepted arc is 180 of a semicircle. So half of 180 is 90. So that's when the inscribed angle is going to be a right angle, is when it's intercepting a semicircle, a 180 measure. All right, we're going to go apply this rule now. Use the inscribed angle rule to find the value of x for each circle. So remember that this angle here is half of the intercepted arc. So the work we would write, the measure of angle A is equal to half the measure of minor arc BC. And we know that this is 28. And the measure of BC, minor arc BC, has an x as its value there. And so we're going to multiply both sides by 2. And we get that x is equal to 56. And our degrees are going to be on this one too, because all of our units are going to be degrees for these measures. Okay, let's go do the other one. This time the x is on the inscribed angle. Remember that the inscribed angle is half of that intercepted arc. So we're going to say that the measure of angle A is equal to half of the measure of minor arc BC. So measure of angle A is equal to half of 117. Do you see this right here? And so the measure of angle A is equal, if you divide that with your calculator, to 58.5 degrees. How'd you do? All right, when two chords of a circle intersect, they form a pair of congruent vertical angles. When two chords of a circle intersect, they form a pair of two congruent vertical angles. The measure of each angle is half the sum of the measures of their intercepted arcs. All right, so check this out. You've got a circle with two chords, and do you see that they're forming congruent vertical angles right there? So here we go. Those are congruent vertical angles. So the two intersecting chords, I'm going to make this smaller so you can still see it in the picture. The two intersecting chords are chord AE. Remember that since that's a line segment, we need to put the line segment on the top, and chord CD. So check this out. Here's AE and here's CD, right? Those are chords. Congruent vertical angles are angle ABC, this guy over here, and angle DBE, excuse me, this guy over here. Okay. Intercepted arcs are arc AC, this guy over here, and DE, this guy over here. The sum of the measures of the intercepted arcs would be measure of AC plus the measure of DE is equal to 110 plus 20 or 130. So let's go back and look at that. 110 plus 20 is 130. And so then the measure of each vertical angle is going to be half of that sum. So we're going to say, and I'm going to do this work down here because it doesn't fit on the line. we're going to say that the measure of angle ABC, one of the vertical angles, is equal to the half of the measure of AC plus DE, those two arcs. And so like we said, it's going to be half of the 110 plus 20, or half of the 130. So each vertical angle is 65 degrees. Half of the 130 is 65 degrees. So this right here is 65, and this right here is 65. And how did we get those numbers? By adding up the 110 plus the 20 and dividing that by 2. Okay, how'd you do? So that's the end of the study guide. Let's go do a couple of practice problems using inscribed angle theorem and using the two intercepting chords. So checking out this first one here, take a peek at it and see what you think. What is the measure of angle BAC? Remember that BAC, an inscribed angle, is equal to half of the measure of that intercepted arc. So measure of BAC is going to be half of the measure of the intercepted arc BC. So this little angle right here is going to be half the measure of that 65. So half of the 65 gives us 32.5 degrees. Notice we can have a decimal. It's totally fine to have a decimal or a rounded answer sometimes. Okay, let's try the next one. This next one, they gave us the angle, and this time they want the arc. So we know that the measure of this angle is equal to 2 times that of the arc when we're going backwards. The angle's half the arc is double the angle. So this time we're going to say that the measure of that arc is equal to 2 times the measure of the angle, which they're calling, I guess they're not calling that x, we'll just put that 85 straight in there. 2 times that 85. So the measure of EF is just 170 degrees. Measure of arc EF. Make sure these arcs definitely look like arcs and not line segments. Okay, last one. This right here, this intercepted arc has a little 22. Remember that the inscribed angle is half the measure of that. So we're going to go measure of angle UXV is equal to half of that 22, or 11. All right, this one's giving us the 55 angle, and they want to know this time the major arc around the edge. So first we're going to find the minor arc, MN, and then we're going to subtract from 360 to find the major. Okay, so we've got measure of minor arc, MN, this guy here, is equal to 2 times that inscribed angle, or 110 degrees. Now that we found that this is 110 degrees, we can go figure out that the rest of it is the difference from 360. So we can say that the measure of major arc, MLN, is equal to 360 minus that 110, or 250 degrees. So there was like an extra step in that one because they asked for the major arc. All right, on this next one, what's the measure of major arc, CAB? Oh, if the measure of major arc, CAB, is 210, what's the measure of angle, CAB? So again, this is kind of a two-stepper. where first we have to do the 360 subtraction. The measure of minor arc CB is the rest of that circle. 360 minus 210, which, take a second to subtract that, I think is 150. So now we know this is 150, so now we can work backwards and get the measure of the angle. CAB is half of the measure of that intercepted arc. So it's half of that 150 that we just found, or 75 degrees. All right, last, what's the measure of XYZ? So again, they want this arc over here. So we've got to do some work to find this intercepted arc first, and then we'll be able to subtract. It's another two-stepper. Okay, so first we're going to find this guy out here by saying that the measure of XZ, minor arc XZ, is 2 times the angle. And so 2 times 115, does that give us 230? Now that we found that this outside arc is 230, now we can subtract and get that the measure of XYZ is equal to 360 minus that 230. And so that gives us 130 degrees. Make sure there's degrees on all these for units. Okay, now we've got the two chords that are intersecting at vertical angles here in the middle. So remember, this final rule goes like this. The measure of one of those vertical angles in the middle, so we're going to say XVY is equal to half of the sum of minor arc XY, so that's right here, plus minor arc WZ. That's this guy right here. Again, make sure these definitely look like arcs. And so it's half of the measure of 86 plus 78. And so that's 164, I think. And half of that is 82. So we just found that one of these is 82. And remember, vertical angles are equal, so we know this other one is also 82. So how did we get that vertical angle inside there? We took half of the measure of both of those intercepted arcs. Okay, pause the video and go try this other one, see what pieces are missing. This one takes some additional steps. All right, for this one, we're going to use the same formula. Measure of angle AED is equal to half the measure of CB plus AD, half the measure of those arcs. So this time, notice we did get CB as 30, but we don't know what this one is. Our unknown is there inside the parentheses. And we were actually given already this measure of AED. Do you see the 55 there inside? So now we're solving backwards for something in the parentheses. So we're going to start by multiplying by 2. So we get 110. And then we minus the 30. So this time x is equal to 80 degrees. How'd you do? Finally, same thing. Let's go try it again. The measure of NOL. That's this outer one. Uh-oh, that's a linear pair to the vertical angle we're trying to find, but we got this. Here we go. So we're going to start with the same formula. Measure of angle, NOP. So I'm starting here, is equal to half the measure of minor arc NP plus the other intercepted arc, ML, LM, whatever you want to call it, either way. And we know that that's 35 plus 65 for those intercepted arc, which adds up to 100. So we get that the vertical angles right here and here are 50. But they didn't ask us for those this time. They asked us for these. So we have to do the whole linear pair thing now, where we know that the measure of angle NOL plus the measure of angle NOP, the one we just found, is equal to 180 by linear pair. And so the measure of angle NOL, we're going to solve backwards to get 130. Okay, did all that make sense? We had to use this idea from Unit 2 about linear pairs. All right, last one. I'd pause the video and go try this one on your own. Let's see how you do. It's doing measure of angle MOP this time. So all it wants is one of the vertical angles that is intercepted, so that's nice. We don't have to do the additional linear pair step. MOP is equal to half the measure of those intercepted arcs. So half of 94, do you see that right here? Plus 26. No, I'm sorry, yeah, 26. Those numbers are small, make sure you zoom in. So half of 120 is 60. So the measure of angle MOP is 60. So what we just found that time are that these vertical angles are 60. All right, go take Apex Quiz 5.5.3 and see how you do.